Hello and welcome to my channel Cosmic Connection. Today's episode is on white holes. Have you ever heard of a black hole? Well, a white hole is essentially the opposite of a black hole. While a black hole sucks in matter and energy, a white hole spews it out. But are white holes just science fiction, or is there a possibility they could exist in the real world? Let's find out. One definition of a white hole. A white hole is a hypothetical region of space-time that is the reverse of a black hole. While a black hole is a region of space-time from which nothing can escape, a white hole is a region of space-time into which nothing can enter. In other words, a black hole sucks in matter and energy, while a white hole spews matter and energy out. However, it is important to note that white holes have only been proposed as a theoretical concept and have not been observed in the real world. 2. The connection between white holes and black holes. There is a theoretical connection between white holes and black holes. In the context of black hole theory, it is proposed that a black hole and a white hole can be connected by a bridge through space-time known as a wormhole. According to this theory, if matter or energy falls into a black hole, it can emerge from a white hole at a different location and time, possibly in a different universe. However, it is important to note that the existence of wormholes is still purely hypothetical and has not been proven through observation or experimentation. 3. The mathematical description of white holes. White holes, like black holes, can be described mathematically using the theory of general relativity. In general relativity, a black hole is defined as a region of space-time from which nothing can escape, due to the extreme curvature of space-time caused by the mass of the black hole. Similarly, a white hole can be described as a region of space-time into which nothing can enter, due to the extreme curvature of space-time. However, it is important to note that the concept of white holes is purely theoretical and has not been observed in the real world. The mathematical description of white holes involves the use of mathematical tools such as the Schwarzschild metric and the Kerr metric, which are used to describe the curvature of space-time around a black hole. These metrics can also be used to describe the curvature of space-time around a white hole, assuming the existence of such objects. 4. The hypothesis of white hole creation. The hypothesis of white hole creation is based on the idea that white holes are the mirror image of black holes and can be formed under certain conditions. According to this hypothesis, a white hole could potentially be formed when a black hole evaporates through the process of Hawking radiation. Hawking radiation is a theoretical process in which a black hole slowly loses mass and energy due to quantum effects. According to some theories, as a black hole loses mass, it could eventually shrink to a point where it disappears, potentially exploding into a white hole. However, it is important to note that the hypothesis of white hole creation is purely theoretical and has not been proven through observation or experimentation. The existence of white holes is still a topic of scientific debate, and it is not clear whether they can actually be formed in the real world. 5. The possibility of white hole observability. The possibility of white hole observability is currently a topic of scientific debate. White holes, like black holes, are regions of space-time that are extremely dense and have a strong gravitational pull. However, unlike black holes, which can be observed through the effects they have on nearby matter and radiation, white holes do not have any matter or energy to observe. Some scientists have proposed that it might be possible to indirectly observe the effects of a white hole on its surroundings, such as by detecting the matter and energy that is spewed out of a white hole. However, it is not clear whether such observations would be possible, and there is currently no evidence of white holes in the real world. Overall, the observability of white holes is an open question in science, and it is not clear whether they can be detected or studied using current technology. 6. The role of white holes in cosmology and the early universe. The role of white holes in cosmology and the early universe is a topic of scientific debate and speculation. Some scientists have proposed that white holes could have played a role in the early universe, possibly as a source of matter and energy during the process of cosmic inflation. Cosmic inflation is a theory that suggests the universe underwent a period of rapid expansion in the moments after the Big Bang. During this period, the universe is thought to have expanded by a factor of around 10 to the power of 30 in a fraction of a second. It is possible that white holes could have formed during this process and played a role in the expansion of the universe. However, this is purely speculative and there is currently no concrete evidence to support the idea that white holes played a role in the early universe. Overall, the role of white holes in cosmology and the early universe is an open question in science and requires further research to be fully understood. 7. The potential use of white holes as a source of energy. The potential use of white holes as a source of energy is a topic of scientific speculation. Some scientists have proposed that it might be possible to harness the energy that is spewed out of a white hole, similar to the way in which energy can be extracted from a black hole. According to this idea, if matter or energy falls into a black hole, it could potentially be converted into usable energy as it emerges from a white hole. Additionally, the idea of using white holes as a source of energy is highly speculative and has not been proven to be feasible through observation or experimentation. It is not clear whether it would be possible to harness the energy of a white hole or how such a process would work. Overall, the potential use of white holes as a source of energy is an open question in science that requires further research and study. 8. The relationship between white holes and wormholes. There is a theoretical connection between white holes and wormholes. In the context of black hole theory, it is proposed that a black hole and a white hole can be connected by a bridge through space-time known as a wormhole. According to this theory, if matter or energy falls into a black hole, it can emerge from a white hole at a different location and time, possibly in a different universe. Wormholes are a type of hypothetical tunnel-like structure that could potentially connect two separate regions of space-time. Some scientists have proposed that it might be possible to travel through a wormhole to visit distant locations or even other universes. However, it is not clear whether wormholes actually exist or whether it would be possible to traverse them. Overall, the relationship between white holes and wormholes is an open question in science that requires further research and study. 9. The debate over the existence of white holes. There is a debate among scientists over the existence of white holes. White holes are a purely theoretical concept that has not been observed in the real world. They are proposed as the mirror image of black holes, with the ability to spew matter and energy out instead of sucking it in. Some scientists believe that white holes could potentially exist based on the mathematical models used to describe them and the hypothesis that they could be formed through the process of Hawking radiation. However, there is currently no concrete evidence to support the existence of white holes, and many scientists are skeptical of their existence. The debate over the existence of white holes is closely related to the debate over the existence of black holes, as both are predicted by the theory of general relativity and both have strong implications for our understanding of the universe. While black holes have been observed through their effects on nearby matter and radiation, white holes have not been directly observed and their existence remains a topic of scientific debate. 10. The connection between white holes and quantum mechanics. There is a connection between white holes and quantum mechanics in the sense that the concept of white holes was developed in the context of black hole theory, which is a field of study that combines the principles of general relativity and quantum mechanics. Black holes and white holes are predicted by the theory of general relativity, which describes the curvature of space-time due to the presence of mass and energy. However, the behavior of matter and energy near the event horizon of a black hole is not fully understood and requires the use of quantum mechanical principles to be described accurately. As a result, the study of black holes and white holes often involves the use of both general relativity and quantum mechanics. However, it is important to note that the concept of white holes is purely theoretical and has not been observed in the real world. The connection between white holes and quantum mechanics is an area of active research and study in the field of theoretical physics. We hope you enjoyed learning about white holes and their connection to black holes and wormholes. While the concept of white holes is still purely theoretical and has not been observed in the real world, it is an interesting and fascinating topic to consider. Thank you for watching, and be sure to check out our other videos on the mysteries of the universe.